Recording. So today's lecture is going to be on array lists. You'll need to use these to store multiple asteroids in your asteroids part 2 assignment. First, some announcements. Your final will be an escape room. Mr. Simon and I have decided to take creative liberties with the kinds of questions we ask you in the escape room. You've done one before. A while ago. You have the option to work in groups or work by yourself. And the questions will take the form of multiple choice, some coding questions, which we want to use some coding bet mixed into there. So be ready. Although our final takes 2 hours of time, we plan for you to take on average an hour to complete the final exam. And let's say you wanted to review and prepare for it. There is this final review for finals worksheet, which has your traditional multiple choice questions for you to look over. And we may be pulling questions from this review. This is completely optional, this AP Java final review, but just wanted to show you all as part of the announcements for today. So these kinds of questions are what you can expect to see from the multiple choice portion of the AP CSA exam. The spring AP exam formatting is still not announced just yet. We don't know whether or not there's going to be a multiple choice portion along with FRQs. Last year, with distance learning, it became all FRQs, where you submit your code, and that was it. That was your grade. There was no multiple choice portion, but those announcements from the College Board have not been announced yet, and we'll keep you updated when we find out. Okay, questions, comments? For those that joined a little bit late, I just went over the final. It will be a escape room. You have the option to work in groups. There will be coding portions. There will be multiple choice portions to it. It'll be like a Google form like we did last time. Right, no questions. Do post in chat when they do come up. We begin our presentation now on array lists. So array lists will be used in part 2 and part 3. It's very much like an array, but that list part of it makes it very useful because you can grow and shrink it in size. That is the main feature that we're going to use in asteroids, as like in part 2 you have like a random or a set amount of asteroids floating around, and later in part 3 when you code up the bullet and possibly collision with like the spaceship and asteroids, you remove asteroids from your big list, right? But you don't know how many to remove until the user triggers that event. In that case, the array list is very useful. Arrays not so much. Arrays are fixed in size. A couple slides that go over the differences and the pros and cons of each. So an array list stores a bunch of objects, and it is an example of a data structure. So far we know 2 data structures. That's the array and the array list. Data structures are constructs that computer scientists use to store and retrieve data. We're novice programmers, so all we know right now are arrays and array lists, but later in your journey in computer science you'll come across stacks, heaps, queues, linked lists, hash tables, trees, a whole bunch of different things like that. And they all store and retrieve data in different ways, and efficiency becomes bigger factor to when you would choose to use one data structure over the other. So for our next couple slides, they are a bunch of examples. We're going to be using this thingy class, which all it does is store a number. Okay, stores a number. Its constructor initializes the number, and then here's a accessor or getter to turn the number. Here's the first step. We need to initialize and declare and initialize an array list. This is what it looks like. Very lengthy. The top line here, array list. Notice the less than and greater than signs, these little carets that surround the type of array list you want. Here, I want an array list of the thingy object I showed you in the previous slide. And that array list is called the list. Then in the second line, we initialize it. The list equals new array list of type thingy in these square, or not square brackets, the carets. Notice you also have the parentheses here. We're calling upon the constructor. You could mush this into one line. Notice the list is shared, so it could look like array list thingy the list equals new array list thingy. But for slides and aesthetics purposes, we separated the two because it's very long. Here's at the bottom a picture, a visual representation of what's going on. We have an array list. It is currently empty, but it exists. Next step, we're going to add something to it. This is how you would do so. First, you create the object. Thingy something equals new thingy 9. So this is an object that holds the number 9 as my num. And now this is the key line of code you should pay attention to. We're adding something to our array list. List.add and then the name of said object. So our list contains that one number 9. It is in position 0. Still uses indices the same way arrays do. Here's a shorthand to adding something to your list. You can, instead of initializing declaring said object, you can just jump straight to new. List.add new thingy 5. Notice now it doesn't have a name, this 5. You can't refer to it as some thingy, but you can refer to it via position and with some other functions in these next couple slides. Down here, the third thing we learned is how to get the size of your list. You use the size function. Okay, so currently our list has two things. When we do thelist.size and print that to the screen, we should see 2. Fourth function we learn is removing things from the list. Let's say that a bullet collides with an asteroid, or later your spaceship collides with an asteroid and you want to remove it. Use the remove function. Notice the input here. At first you may be thinking, okay, remove 1. There is no 1 present in my array list. What's going on? The function here, remove, works by removing the first, like the element at position 1. So this is the second element, second item. Notice 9 is in position 0, 5 is in position 1. That's why thelist.remove1 removes the second thing, which is this 5. After running this line of code, our array list is of size 1. Only the 9 remains, or the object that contains 9, if I want to be super specific. Okay, next thing is to change elements. Notice this one also has some funny syntax, funny spelling. We're changing the first item. Notice this takes in two inputs, two arguments. The first one is the element you want to change, the item you want to change. 0 corresponds with the first item. It is in position 0, the very first thing. That thing is going to be changed to this new object of the thingy that contains the value 3. Thus, what once was 9 in position 0 becomes value 3. This is now the fifth function introduced with ArrayList. You know how to, well, feature, right? Initialize it, add, remove, size, set. Here's the next thing, adding, right? This is one of the more complicated features. I have trouble verbalizing how this is added. This item, so this add, notice it has two arguments. Previously we used add with just one. It adds it to the end of the list, but now we can specify where in the list we want to add it. This one adds it at the front. So before position 0 goes this thingy object that contains the number 2. So notice this one, notice what came in before it. There's the 3, there's the 2. And you could change this to the other indices that currently exist in your list. Okay, so stare at that for a while. Add 0, comma new thingy 2. Next up, we want to access and get certain parts of our list. You use the get function. So here, remember we're still dealing with objects with ArrayList. I guess that's the main difference between arrays and ArrayList. ArrayList only works with objects. Arrays can work with objects too, but they can also handle integers, characters, booleans. What else we got? Doubles, floats. Those are called primitive data types. Arrays work with that. ArrayLists don't. Instead, you have to go through the object version of like an integer, and you'll see examples of that in CodingBat. Okay, so the get function still works with position. We're getting position 1, so that corresponds to the second thing. This one should get you the number 3 stored in another thingy. And here we have some code that prints out that object that contains the value 3. Notice here in the system.print line, we're accessing the 3 using getNum from the thingy class. So let's say we have an array list, yeah. We have a couple elements in it. This is an example of a loop that prints it all out. We initialize, we stop when we get to the end. Here we just have 2 items, so it just needs to run twice. Another thingy, this object is temporary. Get the element at position 0 and 1, and then we print it to the screen. Not so bad. We could condense it, make it shorter. Notice the overlapping green components, another thingy. Okay. So instead, we're replacing that with what's in yellow, doing some substitution. We have a little bit lengthier line of code. Does the same thing. We use the dot operator twice. Harder to read. Shorter in terms of length. But we can do even better than this with ArrayList, to print out all the elements in your array list. You can do it like this. Look, system.out.println, and then you give it the name of your list. ArrayLists are smart enough to handle this case. Feed it in the list, it prints out 2, 3. given that you wrote the accessor method. Nice. So in summary, we broke down line by line what's happening in this program here. I encourage you, as we are learning about ArrayList, to copy and paste this into processing. Change and modify, copy and paste, add in lines of code to this to understand the nuances of how ArrayLists work. Experiment and learn from it. So my seniors that are going on into college, a lot of it's self-studying. You should be doing such practices with code or problem sets or whatever you're going to study later on. So here's a comparison. These two data structures, this array and array list, are very similar. Here are two code segments that do the same thing. They create an array of length 2 and then change it to have 1 and 7 inside of it. One, two, so yeah, there's only 2 elements. So here we initialized it with our array, set position 1, the second thing to be 7, so it contains 1, 7, and we print out that 7. Here in the array, here in the array list version, the initialization and declaration of your array list is a bit lengthier. Notice we're using the integer class. Okay, we can't just use lowercase int, int. We must use capital I, integer, integer, because that's the object version of the int we're so used to. Then we add 1, add 2, we use the set, we set position 1, the second item, to 7. Now we can print out that second element. Here we have a quiz question, practice quiz question, something you may see on your final. Can you go ahead and type the answer out into chat, either privately or publicly? Try not to look at the chat until you get it, I guess, if you do it publicly. What will be the output given these set of calls? So maybe 3 minutes to go over this. If you got it already, you can go ahead and start the coding bat problem set if you haven't done so. You can probably crank out 1 to 2 of them in the remaining class time. Another 2 minutes for people to think through what is currently, or what will be at the end of this list when everything has been modified. You may want to look back at previous slides, especially for the add with 2 numbers in it. Those that have 3 things in their answer, be sure to go back and review how add works. I spent like 2 minutes trying to verbalize how it's being added and ended up confusing myself, but if you stare at it, I hope you get how the add function works with 2 inputs. And if not, after this practice quiz question, you will see. Another 45 seconds. Okay, so at this point, the answers are trickling in. You had 3 minutes to think about it. People are denoting they are unsure by adding a question mark at the end of their responses. Cool. It's very helpful. Let me go over what's happening line by line. You have first here, nums add 13. Our list contains the number 13. Cool. Next, whatever is here, we add to the left. Okay, this is the weird one, and I have trouble verbalizing what's happening here. We add 4 to the left of position 0. We add it as the first element. So actually it looks like this now. 4, 13. Then, now that we have 2 things here, we can add 5 to the left of position 1. So now our list becomes 4, 5, 13. Previously, it was 4, 13. Now, after this third line of code here, it becomes looking like this. Set position 0 to be 7, -7. So now our list looks like -7, 5 is still there, then 13. That's this line, the set 0, -7. And then we remove position 1, so that's the second element, leaving our answer to be the array list containing the values -7 and 13 to be our answer. And if you guys got something different, I think it's because of how the add function works. Adds it to the left, adds it before the given index. I think I'm happy with that explanation. Cool. You'll get lots of practice with this in the coding bat problem set. I hope this example helps. The annotation should be recorded in the lecture video. I hope they show up okay. And in these remaining 8 minutes, you can ask me questions about this coding bat problem, or this practice quiz question, or you can work on these coding bat problems here in your ArrayList 1 problem set due this Friday, along with Asteroids Part 2. But otherwise, you are formally dismissed. Have a good Wednesday. You're welcome to stay. I'll stay around till the end of class. Take care, everyone. Stay warm.